of our workbooks. On page 50 of our workbooks, we're going to talk about percent composition. So there's a percent by mass equation on your equation sheet, which remember is exactly the same that you get on your test and is exactly the same as what is on the back of your green periodic table. So we're going to take this equation and we're going to apply it in a different way. Now, your textbook, chapter 10, covers way more math and topics than we're going to talk about. For example, we're not going to talk about Avogadro's numbers and the number of particles and atoms and things, but that is in your textbook. We're not going to talk about finding percent by mass of just an element inside of a compound. What we're going to do is we're going to talk about percent by mass from a chemical formula in terms of percent composition and items of that nature, because that's our next standard. Indiana wants you to be able to perform calculations to determine the percent composition of a chemical substance. So basically, all we do for that is we're going to use this equation that's in our notes. So you can skip the first equation, you can skip that first little blurb, and we're going to get into this definition now that says the percent composition or percent by mass of a compound is the mass of the element in 1 mole of the compound divided by the molar mass of the compound. Now, I totally messed this up in second period. So luckily, I messed it up with them, so you guys get to have it perfect from the very beginning. So this equation that's right here, the percent by mass from the chemical formulas, circle, star, highlight, asterisk, fireworks, whatever you need to draw attention, this is the equation that we're primarily going to be using. If we look at the percent by mass equation, we're going to need to find the mass of an element in 1 mole of the compound. Remember, those subscript numbers tell you how many moles of that element are in 1 mole of the compound. So basically, all we're going to do for the numerator for that top piece is we're going to take our subscript times our molar mass of the element that we can grab from the periodic table. The bottom number, our denominator, is just the molar mass of the compound. So the very first calculation that you're going to do, more than likely, is looking at the compound you're given and finding its molar mass. That'll be the first step in doing these, and then we're going to put them into this equation. So for example, baking soda, scientific name sodium bicarbonate, formula NaHCO3, is an active ingredient in some antacids. So if you have a stomach ache or indigestion or heartburn, you can take different medications that have different active ingredients. Some of them have baking soda in them. So what we're going to figure out is what is the percent composition. And I thought I changed this and then I didn't. So the percent composition rounded to 1 decimal place for each element in sodium bicarbonate. So how many elements are in sodium bicarbonate? 4. There are 4 elements in sodium bicarbonate. We're going to treat them all as their own separate equation eventually. But what did I say the first thing that we really need to do is? What do we need to calculate? The molar mass of the compound, the sodium bicarbonate. So the molar mass of sodium bicarbonate is going to be equal to how many sodiums are in this compound? Sodium, Na. What subscript is after Na? None. So that means there is 1. My molar mass of sodium is 22.99. Hydrogen. How many hydrogens are there? How many hydrogens are in this compound? 1, Nick says. Oops, not fine. My molar mass of hydrogen is 1.01 on your periodic table. How many carbon atoms, how many carbon moles are in 1 mole of this compound? 1, because we still don't have subscript number. Molar mass of carbon is what? 12.01, which is just the same as its atomic mass. Now, how many oxygens do we need to account for? 3. So we're going to take 3 times the molar mass of oxygen, which is what? 16. So for any of you that were working ahead because you realized what I was doing, does anybody have this number calculated yet? A couple of you do. I'm going to give you guys, Isaac, what'd you get?
84.01.
84.01. What do we think? I think it's right. It is right. So my molar mass, 84.01 grams per mole. So am I going to put this in the top or the bottom of that fraction in my equation? It's going to go on the bottom. Okay. So we're going to treat each element separately. But we're going to use the same equation, but we're just going to use the numbers that only relate to that element. So the top says we need the mass of the element that's in this compound. So we have to find that by taking the moles of the element in the compound times the molar mass of that element. So basically what you're going to end up doing is taking these numbers where we added everything together. Those are going to become the individual numerators in all of these problems. And your denominator is always going to be the same, the molar mass of the compound, 84.01. Then since we're calculating a percent, we just multiply it by 100. And then we don't have to worry about sig figs because in these problems, I'll tell you how many decimal places I want you to round it to. What do you think whenever I get all these percents, and if I added up all of those percents, what do you think they should probably add up to? 100. So I'm going to give you guys 2 minutes. I'm going to start asking for maybe a very brave volunteer that might like to say what your calculator told you the answer for one of these was. Jalen? Just one.
Wait, just like carbon.
Yeah.
I got 14.3%.
14.3 for carbon? Okay. Caleb, what'd you get?
For hydrogen, I had 1.2.
1.2%. Okay. Anybody else feeling brave? Justice?
Sodium, I got 27.4.
27.4. Who haven't I talked to yet? Megan.
For oxygen, I got 57.1.
57.1. These are all correct. So, yes, it's easy when the teacher sets it up and all you have to do is punch buttons in a calculator. But it's really easy to make mistakes and punch buttons in the wrong order.